he didn't write a scientific paper about it. And the same is true for Brian Cox or Neil deGrasse Tyson. They are just commentators. I'm not sure when they wrote the last scientific paper, but definitely they haven't published anything about 3I Atlas. I'm doing the scientific work with students, postdocs, trying to figure out what the data suggests, and I'm engaged in the actual inquiry. And the public is very curious because it's just like a detective story. And suppose there is a detective on the scene collecting clues and trying to interpret clues, but then there is someone looking at the detective and making statements. Who would you rather follow? The person who makes statements from a distance about what the detective is doing? Or would you rather follow the detective as the clues are coming along, trying to figure out what is going on? I mean, it's obvious, and that's why the public is so excited about 3I Atlas, because it shows how scientific work is done. It's not done by making statements. It's not done by bureaucrats, not by commentators. It's done by people who collect the clues, collect the evidence, and then make sense out of them. And of course, when we don't have enough clues, there could be difference of opinions. That should be allowed. Science should not block all opinions except for one, which is the tendency of experts, because they claim we know the answer. But the way science is done is to have a sense of humility and say, okay, let's imagine two possibilities, and one of them is less likely. Okay, but we will collect enough data so that we will show that the second possibility, which we regard as unlikely, is incorrect. And then if the data shows something else, you say, okay, I was wrong, and you learn something new. So that's the way science is done. It's a learning experience. It's work in progress. And all these commentators and bureaucrats who are trying to put a face to the public in which they know what it is, and they are the ones to tell the public what it is, that's not the right approach to doing science.
The last question, Avi, you are becoming famous. I was talking about your reports in Medium. How are you coping with the fame?
It doesn't change anything for me. I was always like that. I would always. It's just that now the subject is of interest to the public. It's not about me. It's about 3I Atlas, and I still wash the dishes at home every day. And in fact, the dishwasher just broke at my home, so now I have to do it by hand until we get a new dishwasher. So yesterday I called the company to order a replacement to the dishwasher. And the person on the other side of the phone call, I've never spoken with this person. I don't know who he is, but he recognized my voice. And he said, "Are you Avi Loeb?" And I said, "Yes." And he said, "I recognize you because I follow everything you say on television, on podcasts." So he knew me just by my voice. And then he asked me after that, he said, it's a great honor. What is the status of 3I Atlas? Before I made my order, he was very curious. So it just shows how interested the public is, how widespread is that interest, and how incredible is this opportunity to get the public engaged and interested in science. I just got an email an hour ago from a mother, a professional, who said that my daughter now wants to be a scientist, and she was talking with me about it and wants to move and pursue an academic career. And every story like that, and this is I heard a lot of those, is giving me the reward that I really want. It's not that my name is recognized. It's the fact that I can excite, inspire young kids and also adults to appreciate the value of science, because that's the only way for us to learn new things, by searching evidence and not by believing stories that bureaucrats and commentators tell us.
Well, Avi, congratulations once again for your success. Thanks for being here with us in Authors TV to talk about this. Thanks for being with us again, Avi. It's a pleasure having you here. Thank you so much.
Thanks for having me. It's always a pleasure to speak with you.
Tres y Atlas. ¿Qué carajos está ya habla de un cambio de rumbo y de una pérdida de masa en un evento difícil de explicar alrededor del 3I Atlas. Ojo, porque el cambio es fundamental. Después de pasar cerca del Sol, los instrumentos de la NASA, no de Aviloev, de la NASA, han detectado algo extraño en el 3I Atlas. Ha perdido alrededor del 13% de su masa, ha acelerado, que se lo decíamos la semana pasada, y ha cambiado, esto sí es importante, ligeramente la trayectoria. Se habla de que podría ser normal si estuviera expulsando gas y polvo, como hacen los cometas cuando se calientan, pero entonces habría que ver una desgasificación en el cometa. Ha perdido un 13%, ha acelerado, ha cambiado ligeramente su trayectoria, marcándonos el camino de un cambio alrededor de lo que se va viendo o lo que va sucediendo en ese movimiento, que ya les digo, si hubiese un proceso de desgasificación todo tendría explicación, no la tiene. Este proceso produce dos señales claras: una cola visible y un empuje natural tipo cohete, pero el 3I Atlas no muestra cola. Las imágenes del 5 de noviembre, de hace 6 días, no ven ni polvo ni gas, lo cual no encaja con el comportamiento de un cometa tradicional. Es decir, ¿podríamos tener un comportamiento cometario normal? Sí, pero no es el caso. No tenía cola, es decir, no veían ni polvo ni gas, y entonces no encaja con el comportamiento de un cometa tradicional. Entonces Aviloev ahí sí que ha entrado en escena, ha dicho, él es el director del proyecto Galileo, ¿no?, que busca señales tecnológicas extraterrestres, que si hay aceleración pero no hay cola, entonces no es un empuje natural. Otra cosa es que de repente veamos que sí hay cola, pero no la tiene. El cambio de trayectoria, dice Aviloev, podría ser un empuje controlado y abre la posibilidad de que pueda no ser un cometa, sino una sonda o un artefacto artificial. Dice Aviloev, si hay aceleración pero no hay cola, pero la NASA ya está diciendo hay aceleración no gravitacional, entonces no es un empuje natural, dice Aviloev. El cambio de trayectoria podría ser un empuje controlado propio del elemento, lo que abre la posibilidad de que no sea un cometa, sino que pudiera ser una sonda o un artefacto artificial. Ya había dicho anteriormente que había otras anomalías, la anticola, una cola apuntando al Sol cuando se acercaba a él, los cambios de color y las variaciones de brillos no típicas. La NASA tiene consenso, Aviloev habla de alternativas. La NASA nos está diciendo, hombre, lo que sí es un cometa interestelar raro. Empezamos bien. Dice Aviloev, bueno, entonces es posible que sea una sonda artificial. La NASA habla de aceleración por desgasificación y Aviloev le contesta, no tiene cola, no es natural. ¿Qué ha contestado la NASA? Tiene una posición conservadora, dice que es un cometa raro, pero que es un cometa natural. Y nos acercamos a la fecha clave. El 19 de diciembre es el día en el que va a pasar más cerca de la Tierra. Si aparece cola, cometa natural, ahí no hay ningún elemento. ¿Y si no aparece? ¿Y si sigue acelerando? Entonces cuidado, porque la explicación de la NASA y de todo este entorno va a ser mucho más complicada. Miren, ayer publicó un artículo, quería contarles esto primero. Ayer publicó un artículo Aviloev en el que ponía más argumentos encima de la mesa. Lo recoge, por ejemplo, el New York Post. Bueno, el artículo lo publicó en Medium y no se podía entrar en Medium, de la sobresaturación de visitas que tenía el portal y que tenía la página de Aviloev. El New York Post dice que un conjunto de chorros alrededor del 3I Atlas, detectados ya, podría usarse para la navegación de una nave espacial. Cuidado, porque empieza a complicarse la explicación. En un artículo de Aviloev, donde pone 5 imágenes alrededor del cometa o de lo que sea, dice que hay o se ve o se percibe ya un conjunto de chorros alrededor del 3I Atlas que podría estar usándose para la navegación de una nave espacial. Y ojo, porque nos habla de un avistamiento de un segundo objeto interestelar en el cielo, que ya tiene nombrecito, se lo digo luego. Pero, ¿qué es lo que plantea Miloev? Cuidado a la hora de interpretar esos chorros alrededor del 3I Atlas, que podrían tener ya o marcarnos claramente el origen artificial, es decir, marcar el camino de una sonda o de una nave espacial o de un artefacto artificial, pero además el avistamiento de un segundo objeto interestelar en el cielo abre la puerta, dice Aviloev, a que pueda ser una especie de flotilla. Vamos, que se va complicando esto cada día que pasa. Las nuevas imágenes del 3I Atlas están mostrando que no encaja con el comportamiento de un cometa normal. Ya les digo que si les muestro las imágenes ven lo mismo que yo, nada. Esto lo ven ellos, los astrofísicos. Las imágenes muestran un punto azul ahí, en medio. Las imágenes del 3I Atlas entre el 8 y el 10 de noviembre muestran algo que no encaja con el comportamiento de un cometa normal y que viene alrededor del cambio de rumbo también. Tiene al menos 7 chorros activos y algunos están apuntando hacia el Sol. Raro, porque los cometas en dirección opuesta al Sol, por la presión de la radiación y por el viento solar. Es decir, antes de llegar al Sol, la cola tiene que ir hacia atrás. Una vez que pasa el perihelio, su perihelio del Sol, la cola tiene que ir hacia arriba, hacia adelante, hacia donde avanza. Pues no está apuntando, algunos están apuntando, perdón, hacia el Sol, marcando el camino opuesto al que debería. Lo que, cuidado, en los cometas, la cola siempre va en dirección opuesta al Sol. Lo que se ve otra vez entre ese 8 y 10 de noviembre. No hay cola típica del cometa. En su lugar hay chorros finos direccionales y algunos son anticolas que parecen empujar hacia el Sol como si fueran empujes dirigidos, lo que ha encendido todavía más la especulación alrededor del 3I Atlas.
Muchas especulaciones en torno al 3I Atlas. Vamos a vivir este momento tan esperado. La NASA publicando imágenes inéditas. Escuchamos ya este directo.
Leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet and all evidence points just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks are interested in this incredible finding that we observed and that that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share it with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars, from our amazing machines that have been roving the planet for 30 years to look for those things.
It is such a rare opportunity for us to be able to observe this interstellar comet. And NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery. Just like Amit said, comet, and NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery. Just like Amit said, comets are tiny cosmic snowballs, and by studying them, we can learn about the environment from, basically where they formed, where they came from. This one came from a different environment from our own, and so we're already starting to see some really interesting differences to comets from our own solar system. 3I Atlas, as you heard, is the third known interstellar object to pass through our solar system, the first one being identified in 2017. While these types of interstellar objects have long been predicted, we are just beginning to be able to find them thanks to the newest technologies with our network of Earth-based telescopes, which are designed to find small, fast-moving objects in space. The NASA-funded Atlas Survey Telescope, which made the discovery, is part of NASA's
Están
planetary defense.
escuchando a los astrofísicos de la NASA, siguen dando cuenta sobre este descubrimiento del 3I Atlas con por parte de la comunidad científica, con este cierre del gobierno que, bueno, pues también ha dificultado el hecho de que se hayan publicado estas imágenes, más de 40 días del cierre del gobierno, pues que ha desatado también mucha controversia. Saben que Avi Loeb, el científico de Harvard, que escuchaban escasos minutos, que ha estado con nosotros en varias ocasiones en Negocios Televisión, dice que la NASA está ocultando las mejores imágenes. Estas son las explicaciones de la agencia.
When it crossed just inside Mars's orbit, which is why the image that Amit just showed, he noted it was the closest instrument physically to the comet, because the comet was right inside the orbit of Mars. Earth was on the opposite side of the sun, which is about as far away as our planet can possibly be from Mars. It's been clear from the moment of discovery that the comet was going to pass on the opposite side of the sun from where the Earth is. However, it was also clear that its positioning behind the sun was going to make observations from Earth very, very difficult. And that is why we are so happy to have our incredible fleet of NASA science spacecraft all across the solar system. And boy, were they ready for this event. NASA's science assets on board our missions have provided the United States the unique capability to observe 3I Atlas almost the entire time it passes through our celestial neighborhood. Everything NASA Science does is interconnected, and nearly 20 mission teams have been working together to really rise to this challenge. 20 mission teams, by the way, and counting. Everything we're learning about the comet is possible because of the distribution of all of the different instruments on our spacecraft with different capabilities. And I'll note that for some of them, we've even pushed our scientific instruments beyond their normal capabilities, beyond the things that they were designed to achieve, to allow us to capture this amazing glimpse at this interstellar traveler. In other words, we can study this comet so well because we have many different assets in different locations, observing things in different wavelengths, in different ways, with different instruments, each set of observations providing a different lens for understanding objects in the sky. So NASA's science team has kept watch on 3I Atlas for nearly its entire journey through the solar system for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going. There will be more opportunities to observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026. So the NASA assets that are gathering observations of 3I Atlas include Hubble, the James Webb Space Telescope, TESS, SWIFT, SPHEREx, Perseverance Mars Rover, Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, personal favorite, Parker Solar Probe, Punch, Stereo, and ESA NASA's SOHO mission. And I'll note that Parker Solar Probe's data were just downloaded yesterday, and indeed, we did catch several glimpses of this amazing comet. The scientific community is hard at work analyzing these images, and everyone, as always, is welcome to take a look. At NASA, we embrace open science. We make all of our data available to the public 24/7, and we invite, in fact, we really want you to tell us what you're observing and what you think about what we're looking at. We're still learning even about what questions we still need to ask, and this, of course, is the scientific process in action. All the data go to a public archive. We get those images as soon as we're able to from all of our eyes in space. As always, I am excited to see what new things we learn about our friendly solar system visitor in the days and, in fact, the years to come. So now I'm going to pass over to Sean. He's going to tell you about what our astrophysics missions have seen. They, of course, were some of the first things to look at the comet, and images from several of them have been available since the beginning of the summer. So I'm going to ask you to set the stage for us. Tell us what we've already seen before we hand over to Tom to tell us all the new stuff. Take it away, Sean.
Thanks, Nikki. Happy to. To give you some background, NASA's astrophysics missions, like all our missions, they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study near-Earth objects or comets like 3I Atlas after they're initially detected. That same powerful gaze that lets these telescopes see distant galaxies, those little red dots you might hear about, they also allow us to observe details about objects like 3I Atlas a little bit sooner. And the earlier we learn about these objects, the earlier we can share this information with the world, including the science community and our partners across the planet that often have ground-based assets or other space-based assets, so that they can conduct additional observations with their telescopes. In this case, our astrophysics missions came together to take advantage of this rare opportunity to study this comet that came to us from outside the solar system. From our flagship space telescopes to smaller missions like TESS and SWIFT, they all have, as Nikki said, different complementary capabilities. They don't just do things that would otherwise be impossible, they do things that even our other great telescopes can't do. So every time we add to the fleet, we add additional capabilities that expand the realm of the possible. In this case, it let us refine the orbit of this structure early on, determine what its structure is and what its composition is, what it is made of. It's a beautiful illustration of why we have not just one space telescope, but a fleet of them, because every one member of that fleet specializes in a different kind of information, contributing a different piece of the puzzle to the total understanding we have from the fleet as a whole. So for example, Old Reliable, NASA's Hubble Space Telescope, celebrated its 35th birthday earlier this year. And not too long after that, in July, it looked at 3I Atlas, not long after we discovered it from the ground. At this point, 3I Atlas was about 277 million miles from Earth. And what Hubble's images revealed was a few things. First, a teardrop-shaped coma of dust coming off that solid, icy nucleus of the comet itself. From these data, astronomers were able to more accurately narrow a few things. Importantly, the size of the nucleus. We now know it's between, at that point actually, we knew it's between 1,400 feet in diameter up to as large as 3.5 miles in diameter. And Hubble also saw that the comet was losing dust, and not just losing it, but losing it at a rate consistent with other previous sun-bound comets that originated from within our solar system, consistent with the physics that we figured out from watching those objects. Now, the last thing Hubble did is it gave us a better understanding of the orbit of this object. Tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope. We added this to our fleet early in this decade. We didn't have it when the last two interstellar comets came on. Now, what James Webb did, and its companion SPHEREx, which we only launched at the beginning of this year, is it added infrared observations. The power of infrared observations is these are colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints from the things that the objects are made of. So with these infrared observations with James Webb and SphereX, we detected an abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust surrounding that comet as it approaches the sun. Those molecular fingerprints I mentioned, those are the little like science wiggles you might see in the top right of these images. We now know from seeing those science wiggles, those fingerprints of those molecules, that the comet has a nucleus rich in carbon dioxide as well as the presence of water ice. Now, the ratio, like we can not just say that these things are there, we can also say, what's the ratio of carbon dioxide to water? And we now know that. We know it's larger than what we usually see in solar system objects. But there's a lot of natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away. But there's other well-understood processes that could also explain it. I'll just to put this in context. Every time we look beyond our solar system and we look at the ratios of carbon dioxide to water, we see, whether it's a star or a planet, different ratios than we see in the solar system. And that's true for this comet as well. So it could mean, and this is the last theory of why those ratios could be different, that these ices could have been exposed.
Señales tecnológicas de radio. Vamos directamente a escuchar las palabras de la NASA, de los miembros de la NASA.
Questions from the media on the phone bridge and through social media. But before we get started, let's learn more about the fascinating comet and share some images. Amit, kick us off.
Hi, everyone. America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star, like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet, and all evidence points to it being a comet. But this came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars from our amazing machines that have been roving the planet for 30 years to look for those things.
Pues ahí escuchamos la conexión desde Washington, D.C. Precisamente estaban hablando los miembros de la NASA en que posiblemente podrían encontrar vida en el resto del universo. Los científicos dicen que están cada vez más cerca de buscar señales de vida en el universo, que están ya practicando y trabajando en ello, que podría ocurrir también en Marte, y que los últimos estudios han apuntado a que podrían encontrar los indicios en nuestro planeta, también en nuestro planeta vecino Marte. Nosotros que vamos a continuar hablando de del 3I Atlas con nuestro compañero Sergio Fernández. Enseguida vamos a ir con él. Mientras tanto, sí que señalar las declaraciones que acaban de hacer desde Washington debido al cierre del gobierno. Dicen que no han podido publicar todo lo que querían acerca del 3I Atlas y que están cada vez más cerca de llegar a esos últimos estudios que apuntan a que podría haber vida en nuestro planeta cercano Marte. Vamos a escuchar a Sergio Fernández hablando de ello.
Buenas, Valeria. Seguimos atentos a la señal que nos está llegando desde la NASA. Vamos a ver la señal en directo hablando del 3I Atlas, dando imágenes inéditas de este cometa.
Science wiggles, where the instrument, the spectrograph, the ultraviolet spectrograph on MAVEN has looked at the comet and also split up the ultraviolet light according to color. So you're seeing three different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from Comet 3I Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the Sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before.
Están viendo la imagen que nos llega desde la NASA con precisamente fotografías, imágenes inéditas del 3I Atlas que, bueno, pues están de alguna forma respondiendo a las teorías de A.B. Loeb, el científico de Harvard, que decía que, bueno, que esto podía ser una nave alienígena. Daba también informes, daba argumentos para, de alguna forma, sustentar estas teorías. Pues la NASA responde a estas teorías, a estas polémicas, dice que el 3I Atlas es un cometa y está mostrando imágenes exclusivas. Seguimos escuchando lo que nos llega desde NASA.
Images to then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. But the answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press *1 to enter the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observation, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one.
Empieza el turno de preguntas para la NASA. Avisamos a nuestros espectadores que a través de las redes sociales pueden usar el hashtag AskNASA, donde pues pueden ir poniendo todas sus preguntas acerca del 3 y Atlas. La primera pregunta es de Associated Press, que está preguntando sobre el tamaño del 3 y Atlas, una de las cuestiones que más polémica está sustentando. Algunos dicen que es algo así como la ciudad de Manhattan. Esta es la respuesta de la NASA.
An indication of rotation, and it's very difficult to discern. So what it's looking like so far is that there's not a big the shape of the nucleus is not very far from being round. Doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin. It would be great, it would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place. And the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in.
Escuchamos a este científico hablando sobre el tamaño del 3 y Atlas. Es una de las cuestiones que ha puesto encima de la mesa en repetidas ocasiones el propio Avi Loeb. La clave está en el núcleo. Nos decía hoy Avi Loeb en su último informe en Medium que la clave está en el núcleo, que va a dar pistas. En este caso el científico está pues refutando estas teorías y nos viene a decir que el tamaño es normal. Saben que 1I, Oumuamua y 2 y Borisov no tenían nada que ver en cuanto a tamaño con este 3 y Atlas, y es precisamente una de las cuestiones que más polémica está suscitando. De momento la NASA echa balones fuera.
All right, we'll take our next question from the phone bridge from Bill Harwood with CBS. Bill, if you're talking, we can't hear you.
Again, this is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. Amit mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft? I doubt you did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of this data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got to point. It's natural to wonder what it is. And we actually love, as Amit said, we love that the world wondered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described.
Segunda pregunta para la NASA. Ya sale el nombre, ya sale la teoría de Avi Loeb. Estaba diciendo este periodista que si en algún momento se han tomado en serio el hecho de que esto pueda ser una nave alienígena, y también pues venía a decir que estas teorías que se están publicando en las redes sociales, dice la NASA que es normal preguntarse, y responde de esta forma: si es o no una nave alienígena.
Pretty well. You kind of know the signatures that you're looking for, and so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else. And that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur, and now, of course, we know better how to look for them, and we now have this amazing Atlas array. You know, we're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any technosignatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as we you know, it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool. It's from something that predates even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little bit, Tom?
You were geeking out so expertly, Nikki, to begin with. So that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine.
Llega la respuesta por parte de la NASA ante estos comentarios de Evilöv, esta pregunta de si es o no una nave alienígena. Dice la NASA que no han visto absolutamente ninguna muestra tecnológica. Decía antes que es normal hacerse preguntas, pero que, bueno, que todo lo que han visto desde 3 y Atlas indica que es un cometa. Refuta todas las teorías la NASA. Bueno, pues sigue echando balones. Atlas es un cometa, que no hay nada tecnológico, no hay nada raro en este 3 y Atlas. Vamos a seguir escuchando sus explicaciones.
Bless them. Of course not, but it's different, and yet it's still coffee. And that's what we have in this case. We have a cometary body. It behaves, it resembles the homegrown comets that we have in our solar system, and yet it's excitingly different in particular ways. It does the same thing comets do. It evaporates carbon dioxide gas. It evaporates water. But it's evaporating more carbon dioxide compared to water. So that's a very interesting thing. Comets evaporate dust, and the dust is broken down. The minerals are broken down by the ultraviolet light of the sun. And comets, we know comets put out nickel, they put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting, really remarkable, and something to be studied in the future. So we're always interested in new ideas. We're always interested in new suggestions, and all ideas are good when they're born. But those that stand the test of time, those that stand up to testing, those that are supported by the evidence are the ones that survive.
All right, we'll take our next question on the phone bridge. And that one comes from Matthew Glasser with ABC.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the...
Seguimos escuchando más explicaciones por parte de la NASA acerca de este 3 y Atlas. Sigue la rueda de preguntas y ojo porque empiezan a admitir alguna cosa que se sale de lo normal. Nos estaba explicando un científico que, bueno, que este 3 y Atlas tiene más níquel que hierro. Dice que es algo muy interesante, que es algo que no pasaba con los otros cometas y que es algo que seguramente se estudie en el futuro. Evilöv ha hecho mucho hincapié en precisamente esto, que la composición, la parte de níquel y de hierro que tiene, pues que no encaja, que se sale de lo normal. La NASA, bueno, pues está aceptando estas ideas de Evilöv, pero sigue diciendo que es un cometa, que no ve nada tecnológico. Vamos a seguir escuchando este turno de preguntas para la NASA.
Tremendous amount of information from hundreds of years of astronomical observation and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects. The way they are distributed through space in the outer solar system show us clues to how the orbits of the major planets may have changed over time in the early solar system. A fascinating thing, and questions that we would never have thought to ask before we knew about these trans-Neptunian objects. Now, interstellar objects like I said before, are new windows, and it's windows that we've never even looked out of before. So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions, the elemental abundances, the mineral abundances may have been very, very different. It would be a different picture if we were seeing the first 3 interstellar objects and we'd say, gee, those look exactly like our homegrown comets. That would have been really interesting, and we would have said, well, maybe our galaxy is a boring place because every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as frozen fossils from their moments of formation, including the things in and now from beyond our solar system.
Sigue este turno, sigue esta rueda de preguntas hacia la NASA sobre el 3I Atlas. Y bueno, una de las preguntas que todos nos planteamos es ¿para qué va a servir esta observación? ¿Qué va a cambiar la llegada de este 3I Atlas? Están diciendo, bueno, pues que lo cierto es que está dando nuevas pistas sobre la galaxia, que está trayendo nuevas ventanas sobre las que podemos mirar y sobre las que podemos aprender de cara al futuro. Seguimos escuchando más respuestas en este turno de preguntas para la NASA.
This visitor that got frozen in time from somewhere beyond our solar system, and that small picture of what that was like when that formed.
And the fact that I love the sort of thought of it as that frozen fossil, almost frozen time capsule. We're kind of privileged. I mean, it's come into our solar system, our sun. We know, we think it hasn't seen a star for a long time. So it's actually warming up and giving us more information. It isn't just about a frozen object coming through and us sort of saying, oh, look, there's a frozen object moving through. But as it's almost waking up and showing us its composition, and that's allowing us to be able to do this great science. If it had just remained frozen all the time, we wouldn't know much about it. But it is the sort of its rendezvous with our star that is allowing us to really do this amazing science. And that to me it makes me feel almost privileged to actually be able to unlock the secrets as this cometary object is coming around and rendezvousing and interacting with our solar system.
All right, let's head over to social media. Nina on X asks, will it hit any planets in our solar system?
No, it will not. I think if you, obviously we're not going to run it again, but please, go online, take a look at go.nasa.gov/3i-atlas and take a look at the trajectory. I kind of talked through it briefly.
Bueno, la NASA, que está hablando del privilegio que tenemos con este 3I Atlas, bueno, pues hablando también del turno que ahora llega para las redes sociales, les volvemos a repetir, hay un hashtag llamado AskNASA donde pueden ir formulando todas sus preguntas. Están haciendo en este momento la pregunta que todos nos hacemos, si en algún momento el 3I Atlas va a impactar en el sistema solar. Incluso había algunos que estaban jugando, estaban poniendo la idea de que pudiese impactar contra la Tierra. Fue preguntado el propio Elon Musk, el CEO de Tesla, que decía, bueno, que podría arrasar un continente entero. Esta es la respuesta de la NASA refutando estas teorías. Dice que la trayectoria no apunta a la Tierra, menos mal.
Discovered in 2017 that was one eye Oumuamua that behaved very much like an asteroid. Again, a little bit like 3I Atlas, a very interesting asteroid, in some ways different from the asteroids we're accustomed to seeing in our solar system. For one thing, it was seemed to be very, very elongated, and while it was inactive, it seemed to be an inert, mostly rocky object. It did show indirect indications that it was evaporating gases in some way. It wasn't around long enough for us to get really, really comprehensive long-duration observations and understand exactly what it was doing. It was the very first one. We saw it for a short time when it was on its way out, in fact, and so we didn't get a great view of that. The second object, 2I Borisov,
siguen formulando preguntas, en este caso a través de las redes sociales, y están cuestionando, bueno, pues algo que todos nos planteamos, ¿qué hace diferente a este 3I Atlas? ¿En qué se diferencia del 1I Oumuamua o del 2I Borisov? Escuchamos la respuesta de la NASA.
Were more in line with what we're used to seeing, and the comet observers regarded it as very much akin to our solar system comets, although in some ways a little bit at the edge of what we're used to seeing. 3I Atlas is in a lot of ways like 2I Borisov, but a bit more out there in terms of things like the carbon dioxide to water ratio.
All right, Svetlana on LinkedIn asks, will the observational data from this campaign be available for open analysis?
Absolutely. Every piece of NASA data, we are delighted to share. We've had open data policy at NASA for a long time. We make a big effort not just to release the data, but also to make sure it's usable, so you can get the tools and things to actually analyze the data as well. And we invite.
Seguimos pendientes de los mensajes que nos están llegando, los mensajes, las declaraciones por parte de la NASA. Por cierto, estamos también atentos a los mensajes que ponen en nuestro canal de YouTube. Vemos que muchos están pidiendo al propio Avi Loeb como presidente de la NASA. Les decimos que cuando acabe esta señal en directo vamos a tener más entrevistas y también van a ver la entrevista que hicimos al propio Avi Loeb hace apenas una semana, en un momento de mucha controversia, en un momento en el que vemos también que muchos espectadores, mucha gente nos está creyendo estos mensajes por parte de la NASA. Sigan insistiendo en que el 3I Atlas es un cometa. Atentos a nuestros mensajes. Pueden seguir, por cierto, toda la comparecencia en nuestro canal de YouTube. En paralelo, nosotros seguimos escuchando a la NASA. Estas son sus respuestas, sus explicaciones sobre el 3I Atlas.
To the phone bridge, our next question comes from Ken Chang with the New York Times.
Hi, thank you. This is for Tom and Nikki. One, of the measurements made so far, what is uniquely different about this comet, other than the trajectory, of course? And two, since perihelion, it looks like there are multiple jets. I was wondering if you could talk about that and the speculation that it might have exploded. Thank you.
Go ahead.
Yeah, thanks, Ken. So some of the differences I already mentioned is the ratio, the carbon dioxide to water ratio, the nickel to iron ratio. Also, there were ground-based observations noting that the polarization of the light reflected off the dust was also unusual. So that's telling us some interesting things about the dust. There are other indications that the physical properties of this dust, maybe the grain size distribution, might be different from the sorts of things that we're used to. The appearance of a sunward tail.
Siguen planteando más preguntas a la NASA en un momento en el que, como saben, bueno, el 3I Atlas ya pasó su perihelio, ya pasó a su punto más cercano al Sol. Estamos ahora mismo a 19 de noviembre, es decir, queda un mes para que este 3I Atlas pase a su punto más cercano a la Tierra y están preguntando sobre esto a la NASA, están preguntando sobre el paso por el perihelio y también una de las últimas teorías que ponía sobre la mesa el propio Avi Loeb, lo hemos contado día a día en Negocios Televisión, estos chorros que estarían saliendo del 3I Atlas y que, bueno, pues también hacen pensar, o el propio Avi Loeb decía que podrían hacer o podrían dar pie a que tuvieran cierta tecnología. La NASA responde también a estas acusaciones.
Take some time to figure out, because it takes time for the actual event that happens on the surface to propagate out to a distance where you can see it with a telescope, but people are going to be mapping what jets there are. It doesn't necessarily mean there was an explosion. Jets can also just mean there are particularly active areas on the surface of the comet where more volatile stuff is evaporating in that one spot than elsewhere and jetting out. We saw this a decade ago with the ESA Rosetta mission at Comet 67P. It got up close and personal with the nucleus and saw frequently that there were jets coming out from specific places on the nucleus of the comet. So that could very well be what's going on here. Can't tell for sure, but that's the sort of thing we've seen before.
The other thing I just want to say that we're expecting to see as more stuff gets thrown off this comet in these jets is at those warmer temperatures, additional things can bake off of it, additional gases can bake off. And so we do expect the composition of the coma to potentially change, or those jets to change over time. And looking at the details of what other molecules we detect beyond the carbon dioxide and water we mentioned is also going to be interesting, especially for that sort of like, what was the area in this, what was this stuff made of in the area it was made, like long time ago.
Our next question is from David Chandler with Sky and Telescope.
Yes, a couple of things. Have you any of these observations showing you anything about any non-gravitational accelerations at this point? And also, can you say a little bit about coming attractions? What observations are in the pipeline that have been made but not released yet? I think the MRO high-rise observations, has that been released yet? And what else is there that's either in the can and waiting to come out, or observations that will be made over the coming weeks as the object comes closer to Earth?
Mm-hmm. I can answer some of that about the non-gravitational accelerations. This is something that we look very closely at for every comet, because that's always something that happens. And just to back up to explain what the question is that as comets evaporate,
Seguimos con este turno de preguntas para la NASA. Seguimos, bueno, pues analizando todas las teorías que hemos ido contándoles día a día en Negocios Televisión, también con este programa especial que hacemos siempre a eso de las 3:30 de la tarde, sobre la última hora del 3 y Atlas. Venimos avisándoles mucho durante la última semana de esta aceleración no gravitacional. Se dice que cuando el 3 y Atlas pasó por superhelio, pasó cerca del Sol, había acelerado. Claro, esto, bueno, pues ha desatado mucha controversia. La NASA también responde a estas acusaciones.
There are some changes to the orbit, but the uncertainties are still fairly large. It's difficult because we can't see the nucleus directly. It's difficult to get a very, very precise track on exactly where it's going. But so far, the non-gravitational accelerations have been very much on par with the sort that we see in solar system comets.
In terms of future observations, this is a situation where, because this is only the third time we've had an opportunity to look at an object like this, everyone that is in control of a telescope wants to look at it because it's a fascinating and rare opportunity. I know that our colleagues from the Keck Observatory have looked at it. I believe that we're going to look at it again with JWST in December. We have some other ground-based facilities that are giving us additional compositional information as those additional molecules bake off.
Ojo con esto, porque la NASA está admitiendo ahora que no son capaces de seguir la trayectoria del 3 y Atlas. Dice que no pueden obtener una imagen muy nítida del núcleo y que por eso, bueno, su percepción es que este 3 y Atlas no está acelerando, pero a pesar de las imágenes que han mostrado y que vamos a repetirles más tarde, la NASA está admitiendo que no puede seguir la trayectoria del 3 y Atlas. Dice que hay muchas incertidumbres todavía, sobre todo porque no pueden acceder, no tienen una vista perfecta de su núcleo. Vamos a seguir escuchando a la NASA. Esto es muy importante. Dice que no saben la trayectoria exacta del 3 y Atlas.
Track it longer than anyone else, partly because of its ability to kind of look long and deep rather than sort of across and wide, and the fact that it looks in the ultraviolet, in the infrared, so it can kind of see the dark objects. And so I'm really excited about just sort of, tracking it to the very end. Also noted we're downlinking data from missions. I mentioned Parker Solar Probe because I just heard before we came on that we got some data and we'd seen the comet. I haven't had time to look at the data yet, but all of those things are coming up as we are getting more and more data coming down to us from those missions. And then as both Sean and Tom talked about, just really making sure we're sharpening up those images and really, making sure they're calibrated. Right now we're putting out almost the raw images. We're putting out things quickly so everyone can see them, but we'll take some time and do some real sort of deep looking into those and do some more of the spectroscopy. Tom showed a really great example of kind of looking through the atmosphere of Mars, take out that hydrogen, take out the hydrogen from our solar system, and then let us look at the hydrogen that's coming from the comet. So we'll be doing a lot more of that as we move on to do great things with NASA science.
All right, that's a great lead into our next question on social media. Elijah on X asks, what kind of processing were the images subjected to and why did they need it?
Want to take that?
The images that were released received the sort of standard processing that we do between the raw data that comes down into a telescope. That, as Nikki said, we need to make sure for scientific accuracy that they're calibrated against the other observations, and we account for anything that the telescope is doing in that moment. And so that it would be our standard set of calibrations and normalizations for a object of this type, which is to say a comet.
I can add a little bit more to that. As Nikki said, our desire was to
Seguimos atentos a los mensajes que llegan desde la NASA, atentos también a los mensajes que tenemos en nuestro canal de YouTube. Vemos algunos que dicen que siguen creyendo a Ivy Loeb, otros que hablan de la burbuja de la inteligencia artificial. Están en lo cierto, eso de las 10 de la noche vamos a comenzar programación especial mirando estos NVIDIA. Vamos a contar también con nuestro compañero José Antonio Bizner. Nosotros seguimos mirando a estos mensajes por parte de la NASA y a la pregunta que estaban planteando ahora. Les estaban diciendo que cómo así el procesamiento de estas imágenes. Escuchaban ahora la científica que, venía a decirnos que todavía tienen que elucubrar, que todavía tienen que terminar muchos detalles de estas fotografías que todavía están siendo procesadas. Vamos a seguir escuchando los mensajes, las explicaciones de la NASA.
Yet to be done to figure out exactly what that scattered light contribution was and remove that from the image so that what we show in the image is entirely what was there in the sky and not something just made by sun glints off the spacecraft hardware.
Yeah, and sometimes I think you showed the Soho image where we actually stacked a couple of images because a single image, you wouldn't be able to see it. It would be too faint. But if we stack a couple of images together, then you can actually start to really make out what that comet looks like.
Okay, next, Gail on Facebook asks, how can an object like 3I Atlas come from so far, moving as fast as it is, and not hit anything?
Orbital dynamics and space is really, really huge. And so, even it is amazing to think about just how big even our solar system. And so to give you the Voyager spacecraft, Voyager 1 is now 1 light day away from Earth, which means when we send a command or we send a photon from Earth, it takes a full day for that photon to arrive at Voyager. And Voyager is only just outside kind of what we think of as the edge of our solar system. And so space is vast. Yes, this thing is moving quickly, and yes, it came from outside our solar system. But the probability of it actually hitting something is so small, because everything has to align. It's also not quite in the ecliptic plane. It's not quite in like our normal. If you think about sort of looking side on at our solar system with the sun, and then you put the planets kind of in a row. Normally, everything sort of orbits in this plane. This is slightly tipped. Not unusual because it's not gravitationally bound to our sun, but it's slightly tipped. That makes the probability of it hitting it almost even greater.
If I can play with a scale model solar, if you make a scale model solar system where the sun and the Earth are 1 foot apart, that's about 1 foot. The sun is a P. The Earth, you need a magnifying glass to see, it's so small. The entire solar system will just barely fit in your house if you squeeze a little bit. And the next nearest star is over 50 miles away. So they call it space for a reason. Most of it is space.
Okay, we'll head back to our phone bridge. Our next question is from Brandon Spector with Live Science.
Hi, I wanted to ask about the age of the comet. You mentioned there's circumstantial evidence that it's much older than our solar system, but how can we constrain that age a little more? And what will that tell us if it is indeed much, much older than the solar system?
I can start that, but I'm going to pass it to Sean to talk about ages in the galaxy.
Okay.
So cutting to the end, the bottom line is going to be, it's probably going to be really hard to get a more precise figure from one object. I think what we're looking at in the future, as we discover more of these, when we get to the point where we have maybe a few dozen of them and look at the distribution properties, we may be able to get a better handle on what the distribution of ages is. So what's going on here is that it takes the sun 240 million years to orbit around the center of the galaxy, and we're doing that with a neighborhood of stars. So we're all going around the center of the galaxy. The relative motions between stars in our solar neighborhood is sort of 10-ish, 15, and sorry, I have all these numbers in my head in metric because that's the way I learned them, but 10 or 15-ish kilometers per second. So what is that? That's about 25,000 miles an hour, I think. And 3I Atlas is coming through at a speed of 60-something kilometers per second. So that's 3 times faster.
Seguimos escuchando más preguntas sobre este 3i Atlas, ahora mismo cuestionando acerca de su edad. Decía este físico, decía este científico, bueno, pues que tienen muy pocas pruebas, que estamos en el 3i Atlas y hasta ahora, bueno, pues solo tienen 2 con los que comparar. Dice que están recabando muchos datos y que, bueno, este estudio sobre el 3i Atlas también está dando muchas claves para lo que pueda suceder en el futuro. Tarde o temprano seguramente tendremos otro 4i. Seguimos escuchando estos mensajes mientras ya les avisamos que en los próximos minutos volveremos con la entrevista de A.B. Loeb.
And so that's the circumstantial evidence that makes us think that 3I Atlas came from a solar system that had larger motions relative to our solar neighborhood and is older. But it is a circumstantial and probabilistic argument.
So I'm just going to take this opportunity to brag about our telescopes and the James Webb Space Telescope in particular. This blows my mind. We have data from galaxies closer to the origin of the universe than we have data from rocks closer to the origin of Earth, right? In other words, like if you pick up the oldest rock that we have from Earth, it is further away from the origin of Earth in terms of hundreds of millions of years than the amount of time there was between the origin of the universe and the earliest galaxies that JWST has now observed. And that's part of this story of how well we understand not just the history of our home planet, but the history of the entire universe that it's a part of. And now this is just another part of that story of the local neighborhood that our solar system is a part of.
All right, our last question for today comes from X and asks if we can see grains of sand on Mars. How is the clearest photo we can see for 3I Atlas, what we've seen?
So because we're closer to the grains of sands on Mars, right? And so the JWST can only get like these single pixel blobs of the faintest galaxies, the furthest away galaxies in our universe. And because 3I Atlas is in our solar system, we can get the images and the compositional information with JWST. As it got closer to some of the planetary spacecraft Tom was talking about, they can't even see these galaxies, but because 3I Atlas was closer to them than they were to JW, they got really good images of the object as it passed by.
Right, as you said, we can image individual grains on Mars because we have spacecraft standing on Mars.
Right.
But even our closest spacecraft to 3I Atlas, we're still 19 million miles away.
And it's going too fast for us to send something there to intercept and get that close to it. So that's just not that we just don't have the. If we could. We would, we would be there up close and getting those grains.
All right, well, that's all the time we have for today. Thank you so much for joining us. Be sure to follow along with NASA.
Hasta aquí ha llegado esta señal en directo, estas explicaciones por parte de la NASA, prácticamente una hora respondiendo algunas preguntas en X, algunas preguntas en las redes sociales, no las nuestras. Ya les decimos que desde Negocios Televisión hemos intentado cuestionar, hemos intentado plantear preguntas, pero no hemos tenido esa suerte. Hemos visto imágenes inéditas del 3i Atlas, hemos visto también algunas explicaciones por parte de la NASA, por ejemplo, sobre estas teorías que hablaban de que tiene varios chorros, otras teorías que hablan de que hubo una aceleración no gravitacional cuando este 3i Atlas alcanzó su perihelio. Bueno, la NASA ha intentado ir echando balones fuera, hablaba también sobre su tamaño, sobre la comparación con el 1i Oumuamua o el 2i Borisov. La NASA dice, porque tienen una muestra muy pequeña y que poco a poco están recabando datos y están intentando también sacar conclusiones acerca de este 3i Atlas. Enseguida vamos a seguir con más expertos, vamos a seguir con más analistas, pero vamos a escuchar lo que nos decía A.B. Loeb, el científico de Harvard, que hemos visto que ha mencionado mucho en nuestros comentarios en YouTube. Saben que bueno, en las últimas semanas ha estado varias veces en esta casa, ha estado varias veces en Negocios Televisión y les emplazábamos nosotros al próximo 19 de diciembre. Va a ser el momento en el que 3i Atlas pase cerca de la Tierra, va a ser su punto más cercano a la Tierra, y el científico de Harvard nos decía hace apenas una semana que espera que no tengamos un regalo para Navidad. A.B. Loeb hablaba de esta forma sobre el próximo 19 de diciembre y sobre el paso más cercano de 3i Atlas a la Tierra. Este es el mensaje que lanzaba sobre Navidad.
We will find the answer to the fundamental question, is it technological? Was this trajectory designed by some intelligence? Or is it a natural object that happens to be very rare and unusual relative to the rocks that we would have expected? And the answer will come in the coming weeks. It will get closest to Earth on December 19th. And that's just 6 days before Christmas. And my hope is that it will not deliver any unwanted gifts to us on Earth for the holidays.
Seguimos en Negocios Televisión escuchando las declaraciones por parte de A.B. Loeb, escuchando las explicaciones por parte de la NASA y, como les decíamos, contando con los mejores expertos. Ya contamos con Darryl Seligman, Professor of Astronomy in Michigan State University. Hi, Darryl. Thanks for being here with us.
Thanks for having me. It's great to
It's a pleasure to have you here. I would like to know what is your answer about these messages from the NASA. What do you think about this explanation?
Yeah, no, this is super exciting. So it's really, really exciting to see that we have finally presented all of the data that we took on this object in the last couple of months to both the scientific community and the general public, because essentially what happened is that we have 3i Atlas discovered this very exciting interstellar object. We only have one shot at it. So the observations that we get now are the only chance in not only our lifetime, but the lifetime of the solar system to study this object, because it comes and goes and it's never coming back. And it's a time capsule of information from another planetary system outside of our solar system. And then it was as exciting as it was to kind of be in part of the discovery in July 1st, we then had the unfortunate event where we basically weren't able to point our ground-based telescopes at 3i Atlas during the most interesting time when it was closest to the sun. You really want to look when it's closest to the sun, because that's when you get the most holistic view of the nucleus of a comet. And the great thing is that although we couldn't see it from Earth, all of NASA's space-based assets were able to look at it. And they just weren't able to release that information because of the government shutdown. So it's extremely exciting to get all the information released right now.
Darryl, I think that the question is clear. Can we trust in the NASA?
Can we trust? Sorry, could you repeat the question?
Yeah, in the NASA, can we trust in the image explanations about how the NASA, can we trust in them?
Right. Yes, absolutely. So I mean, this is kind of how science works. Usually, it's not just a big press release. So it kind of had to be this time because we had all of this information that wasn't able to get out because of the government shutdown. What's going to happen is that all of the data that is taken will be submitted to journals, scientific journals, and then peer reviewed. And then the statements that we make about the conclusions that we draw from that data about 3i Atlas will get peer reviewed by experts who work on comets and solar system objects and interstellar objects. So for sure, we can trust in this information coming from NASA, and we can look forward to the next several weeks for seeing what the exciting results and interpretation from that data are about 3i Atlas.
And Darryl, what do you think about 3i Atlas? Do you think that is an ordinary comet?
So that's a great question. So I do not think it's an ordinary comet in the sense that every comet is not an ordinary comet. So there are lots of ways to answer this, but 3i Atlas isn't an ordinary comet because it's from outside of our solar system. Comets usually behave in different weird ways, but if you look at the comets in the solar system, there are some trends that appear that 3i Atlas seems to have been an outlier with regards to. So 3i Atlas, for all intents and purposes, is displaying every phenomenon that we know that comets display. So it has a nucleus, a rocky, icy nucleus, which is expelling gas. And basically, by looking at that gas, it tells us something about the nucleus. So the reason we're able to make any statements about the observations that we have obtained on 3i Atlas to this point is because we have gotten very good at studying comets. So the fact that 3i Atlas is kind of behaving like a comet is the reason that we're good at getting measurements and observations of this object. It is not like a typical comet, though, because one strange thing, I mean, you just heard NASA's press release. So Tom Statler was saying some of the kind of interesting properties. To me, the most interesting property about this object is that it seems to be most of the gas coming off of it is not water. So the fact that we've seen a lot of CO2 driving the activity, carbon dioxide coming off of 3i Atlas tells me that it's potentially something very different from our regular solar system comets. And that one interpretation of that is that it formed in a similar manner to the solar system, but at a much larger distance from its host star. So where you basically need to be at a region of an exoplanetary system that's very cold to have cold temperature-wise to have CO2 incorporated in the ice. So on the one hand, I'd answer you with 3i Atlas, yes, it is not like a typical comet because it has all these interesting properties that maybe is telling us something about how planet formation is different throughout the galaxy, but it is clearly a comet.
Derrilan, what do you think about the size, the speed of the 3i Atlas? Why is so different from 1A Oumuamua or 2I Borisov?
That is an excellent question. So I think, okay, so to answer that question, we need to be more specific about what differences we're talking about. The another difference of 3i Atlas with both the Oumuamua and Borisov is that it was moving much faster when it entered the solar system. So that, I think, is telling you, basically, the faster an interstellar object moves through the galaxy, the older it is. Because as things orbit in the galaxy, as time moves on, they basically scatter off of things like giant molecular clouds. And the cumulative effect of all of these scattering events makes objects move faster. So I think the fact that 3i Atlas is moving so much faster, than Oumuamua and Borisov is potentially telling you that it's a much older object, potentially even older than the solar system. And that really could be what's exciting about that, is that it could be telling you that the processes by which planets formed and comets get scattered and ejected that we know happen in the solar system, potentially were happening just as efficiently and vigorously in the Milky Way at its very earliest stages. So when the Milky Way was a very young galaxy, we were also making planets and comets the same way that we do them now.
And Errol, we are talking a lot about this 3i Atlas because of Avi Loeb, this scientific of Harvard. What do you think about her hypothesis?
Well, I mean, I think that you just watched NASA's press release. It's pretty, I mean, the reason that we're able to get all of these exquisite measurements of 3i Atlas with our space-based assets and with the ground-based observations and do things like what I've been talking about, measure its speed at speed when it was entering the solar system, measure the composition, how we know that there's CO2. You heard Tom Statler at NASA talking about the weird properties of the dust grains, like the polarimetric measurements were a little different than we normally see. It seems like maybe there are larger dust grains than in typical solar system comets. The fact that we are so good at making all those measurements is because we have been making those measurements of comets for decades. This object has, ever since we discovered this object, it has displayed every characteristic of a comet. So the reason that we're able to get these interesting measurements is because it is a comet and we have been studying it and measuring it just like we measure every other comet.
And do you think that AB Loeb is helping or is harming the scientific community?
I think that is a question that the scientific community in general feels maybe split on. So I think it depends on who you ask.
Well, waiting for more reports about AB Loeb, I would like to ask you about if you think that we had a 4i in the future. You think that 3i Atlas will be the last?
For more interstellar objects in the future, is that what you were asking?
Yeah.
Oh, yes. So this is extremely exciting. So even just discovering a Oumuamua in the last 10 years, I mean, not even 10 years, but approximately 10 years, if we discovered a Oumuamua in Atlas, forgetting about Borisov even, that tells you that there's about one similar object in the inside of Earth's orbit at any given time that we're not seeing. And that corresponds to about 100,000-ish interstellar objects inside of Neptune's orbit. And if you go to the whole galaxy, we're talking about something like 10 to the 26 interstellar objects in the galaxy. So that means for sure there should be many more of these objects that we could detect. It is not at all like 2017 was special and that was the only time an interstellar object came through our solar system. We just managed to discover it at that point in time. So for sure there are other objects out there to discover, but we just almost contemporaneous with the discovery of 3i Atlas, we had the first light of the Vera-Rubin Observatory, LSST. LSST in the Atacama Desert is going to look at the entire it is currently operating, it is looking at the entire southern hemisphere every night, basically, to about 5 orders of magnitudes more sensitivity than any all-sky survey that we've ever had before. And that means that we should be just that much better at discovering interstellar objects in the next several years. So I expect that we'll start discovering these objects at least a couple every year from now on.
And Daryl, what can we learn about these 3i Atlas for the future? How can help to the scientific community?
So okay, I'm just getting excited because thank you for that question, because I've also been thinking about that. One exciting thing is that 3i Atlas, we're going to be able to look at it through the spring, maybe even into the summer. So we, as astronomers, we can get data on this fantastic object for several months. And there is data at any point in time on 3i Atlas throughout its trajectory is valuable. You heard the people at NASA talking about that. Data when we couldn't look from Earth, when it was closest to the sun, was super valuable because that was when the comet's at its warmest. However, you also heard them talking about, there was a question in the Q&A that they addressed about what was the processing like as 3i Atlas traveled through the galaxy. So we have an opportunity not only to learn about exoplanetary systems, but what happens to comets as they travel through the interstellar medium of the galaxy. So as we look at 3i Atlas as it kind of leaves the solar system, that's potentially going to tell you about material which is further in of the nucleus of the object, and maybe tell you about how that processing in the interstellar medium occurred on an interstellar object. That's like, effectively, that is something that we've tried to learn about in lab experiments for the last couple of decades, but the interstellar objects like Oumuamua, 2I Borisov, Atlas, and then all of the future ones we're going to discover, that gives us an unprecedented window into not only planet formation around other stars, but what is the environment like as these objects move in the interstellar medium.
And the last question, what can we expect from the 19th of December? Could we see a better image of this 3i Atlas?
Right, so for people at home interested in looking at 3i Atlas, it will not be, you cannot see it with just your eyes. So it's not a naked eye comet, but it is possible from some locations on the Earth that you'd be able to see it with a good amateur astronomer telescope. So you don't need a big fancy telescope like LSST or James Webb Space Telescope to see this object. It is possible, if you have a powerful enough amateur telescope, then just with an eyepiece to try to look at this object if you're kind of in or close to one of the right areas where you could see it from. So I'd recommend definitely wherever you are now, looking up when and where you could see the object from, and then trying to find a place which is far away from light pollution, so far away from city lights, and as high up as you can get to try to stake out a view on when it's close in December, when it's closest to the Earth. You don't also have to go that date. You could go basically starting after December 1st, but you know, the later weeks in December will be better, but you could potentially see it with an amateur telescope. In fact, I've been getting images that amateur astronomers are sending me with their telescopes pretty much every day. So that can be a very valuable, not only can it be exciting for you to go and look at it, that can be a very valuable contribution to the scientific community.
Well, waiting for this 19th of December, Derry, thank you so much for being here with us in Northwest TV. It's a pleasure having you here.
Thanks for having me.
Thank you. Nosotros que vamos a seguir dando vueltas a este 3i Atlas, van a poder seguir toda la comparecencia, también la entrevista que hicimos con Avi Loeb hace apenas unas semanas en nuestro canal de YouTube en paralelo, todas las últimas horas sobre el 3i Atlas en paralelo. Nosotros vamos a mirar lo que es otra de las noticias del día, si estamos o no ante.
Thanks for having me. It's a great pleasure.
Avi, I would like to ask you about your last interview. You said that the 3i Atlas doesn't appear to be an ordinary comet. Could you explain it in detail, please?
Yeah, the most interesting information is from the last few days. It passed near the sun on October 29th, and there seem to be 7 jets coming out of it, according to the latest images. And these jets propagate a distance of up to a few million kilometers. And that means that they were able to penetrate through the solar wind because some of them are going towards the sun. And I calculated that the amount of mass carried by these jets is 5 billion tons. It's a lot of mass. And that's in case this object is natural, in which case the jets are produced by pockets of ice, either carbon dioxide ice or water ice. But in that case, in order to get so much mass coming out, the area needs to be very large, of an object bigger than 20 kilometers in diameter. And that is difficult to accommodate with early data that we had on 3i Atlas. So one way to get a large area is if the object broke up into pieces so that the area is much bigger when you sum up over all the pieces. So in the case of a natural object, maybe it disintegrated. Maybe there were some fireworks next to the sun a week ago, and we will find out very soon because these fragments will get separated by the tidal gravitational field of the sun. So the sun acts gravitationally differently on the different fragments, and they will separate. However, if it's a technological object, it could be that the jets are used for propulsion, that these are thrusters. And we know that technological jets have a speed, usually of the gas that comes out of them, that is much larger than expected for a natural comet, by 1 to 2 orders of magnitude for human-made technologies. And if we have some alien technologies here, it could be even larger. So in that case, the speed of the jets would be much larger than expected, and it will carry much less mass. The fuel has to be a small fraction of the mass of the spacecraft. So there is a clear test in the coming weeks for us to study those jets, figure out their speed, composition, the mass that they carry, and from that we will learn whether it's a natural comet or something technological. Originally, the anomalies of 3i Atlas were that it was very big already. We knew that from the start, 1 million times more massive than the first interstellar object, and that was surprising. Why are we getting such a big delivery in the third object? We should have obtained such a big object maybe once per 10,000 years. But another anomaly was the trajectory, which was aligned with the orbital plane of the planets around the sun. And we will find the answer to the fundamental question, is it technological? Was this trajectory designed by some intelligence? Or is it a natural object that happens to be very rare and unusual relative to the rocks that we would have expected? And the answer will come in the coming weeks. It will get closest to Earth on December 19th. And that's just 6 days before Christmas. And my hope is that it will not deliver any unwanted gifts to us on Earth for the holidays.
Well, Avi, waiting for this 19th of December, I would like to ask you about some critics. There are some people saying that the extraterrestrial technology hypothesis is so premature. What is your argument for these people?
Well, we need to decide whether it's natural or technological based on the data. And we just had circumstantial evidence until now, and we need to wait for the coming weeks. I'm not saying it's one or the other. It's most likely a natural comet, but we need to check to make sure, because otherwise it could be some black swan event that is unlikely, but nevertheless surprising. And you shouldn't be surprised hearing comet experts say that it must be a comet, because just like AI systems that are saying things based on the training data sets, the same is true about comet experts. They were trained on data sets that involve only comets. So whatever they see in the sky, they will say it's a comet. Even suppose there is a spacecraft or an object that maneuvers without any cometary tail, they would argue it's a dark comet. In other words, a comet where you don't see the gas and dust around it. That's what they said about Oumuamua, which exhibited a non-gravitational acceleration. This was the first interstellar object discovered back in 2017. And the comet experts said, it's still a comet, it's a dark comet, even though we don't see the signatures of a comet, which is gas and dust around it. So the point is, they are just like AI systems. They are trained on comets, and they will say anything in the sky is comets, including spacecraft could be called dark comets because you don't see a cometary tail, and they can maneuver and have non-gravitational acceleration. So my point is that we should just be guided by curiosity and the humility to learn what this object is, rather than the arrogance of expertise.
Well, Avi, waiting for more answers, I would like to ask you about some of your last reports in Medium. You are becoming very famous, Avi. Did asteroid 3I Atlas just disintegrate near the sun? Is this true?
Sorry, what? Can you repeat?
Yeah, the 3I Atlas just disintegrate near the sun. Is true these reports? Are true these reports?
I haven't seen, where did you get that information?
Some pages, some media talking about this, that the 3I Atlas pass very near of the sun and it disintegrate. Yeah.
Well, that's potentially based on what I said before, where I said that if it's a natural comet, then the amount of mass loss that is required to power the jets that we saw coming out implies a very large surface area, potentially, of fragments. But this is just in case it is a natural comet. We haven't seen in any image multiple fragments as of yet, as far as I know, unless something new was discovered today. I have to check. But until today, we have not seen multiple components, fragments, in the images of 3I Atlas.
Avi, we know that 3I Atlas has sent its first signal to the Earth. What does this discovery mean for the scientific community?
Well, if we receive a technological signal in the form of a radio signal, or we see some artificial lights, or we see the heat of an engine that is providing much more power than expected from sunlight impinging on the surface of an object, then we would know that we're dealing with a technological civilization that is far more advanced than we are, because the biggest rocket that we produced is Starship, which is smaller than 100 meters, smaller than a football field. This object is the size of a city, and we don't have the technologies as of now to launch such a big thing to space, especially not interstellar space. So we will have a long learning experience trying to figure out what this is. But of course, if it happens to be a natural object, it's still surprising that it's so big. We will have to understand what are the astrophysical factors that produced this kind of a big object made mostly of carbon dioxide, if it is natural. And moreover, why was it sent in the plane of the planets around the sun? Perhaps there is some astrophysical reason for that. But we have to explain those anomalies. We can't just say it's a comet and that's it, case closed. We need to figure out why it has these unusual properties, because we must be missing something.
We are missing something, and we are waiting for the NASA. As the government shutdown ends, do you expect NASA could release these images of the 3I Atlas? We know you are pressuring about this. You are pressing.
Yeah. Thanks to